Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over section 5.4b of our virtual college algebra text on logarithms and exponents. In this presentation, we're going to be taking a look at how to rewrite exponents in logarithmic form. A sample problem that I'll be attacking in this presentation is depicted here. We're to rewrite in logarithmic form the exponential equation 1 over 11 squared equals 1 over 121. Don't forget, we have 10 practice problems at the end of this tutorial that I would like you to try out in order to demonstrate mastery of the contents of this presentation. If this sounds like what you're looking for, don't forget to hit the like and subscribe buttons. And to gain access to our entire college algebra, Algebra 1, 2, Geometry Pre-Calc, and Calc courses, take a look at the links in the description below. Alright, so to get us started, this is our website, mathgotserved.com. If you take a look at the formula collection, you're going to see the formula that's going to be guiding our problem solving process in this tutorial. And it's known as the inverse properties of logarithms. Okay, on the mathgotserved.com/college algebra, you should be able to get access to these formulas. So take a look at the first formulas in both boxes. You're going to see what we're looking at today. The first one is log base a of a to the x is equal to x, and the second is the natural logarithm of e to the x is equal to x. In both cases, we can see the interaction between a logarithmic function and an exponential function with identical bases. Ladies and gentlemen, they are inverses, so when you compose them with one another, they basically cancel each other out, and you're left with the value of the power, which is x in both cases. All right, let's take a look at the instructions for the examples that we are working on. Instructions are as follows. We are to rewrite each exponential equation. Rewrite each exponential equation in logarithmic form. Okay. All right, so the first one, we have 7 raised to the second power is equal to 49. So we have to write this exponential equation in its equivalent logarithmic form. All right, so let's do it. So what we want to do is we want this exponent canceled out. All right, so how do we go about canceling this exponent? Remember the formula we just looked at, and also the previous installment of this presentation, we talked about the inverse relationship between logs and exponents, okay? So if you want to get rid of an exponent, you use log and vice versa. So the base of this exponent is 7 on the left side. So what does that tell us? It tells us that log base 7 is what we need. So we're going to take log base 7 of both sides of our equation. So log base 7 of the left and log base 7 of the right. Okay, this is not a multiplication operation. This is a composition operation. So we're taking the log of both sides. On the left side, since the base of your log and exponents are identical, guess what? They cancel each other out. Alrighty, and we'll have the final answer 2, just bring down the exponent, equals log base 7 of 49. So this is the equivalent logarithmic form of the original exponential equation. Alright, moving along, let's take a look at question number 2. Let's say we have the exponential equation 9 raised to negative 2 is equal to 1 over 81. So we are to rewrite this in its equivalent logarithmic form. All right, so 9 to the negative 2 is equal to 1 over 81. We're going to be replicating the steps that we executed in number 1. So the question is, what log of what base will be used to cancel this exponent right here? It's basically the log with the base that's the same as the base of the exponent, which is 9. Okay. So we're going to take log base 9 of the left side of the equation, which is 9 to the negative 2 power. And that's equal to log base 9 of the right side of the equation, 1 over 81. On the left side, we see that the base of the log and the exponents are identical, so they basically cancel each other out. And we're left with the final answer, -2. Just bring down the power, okay? -2 is equal to log base 9 of 1 over 81. Ladies and gentlemen, that's the answer to question number 2. The logarithmic form that's equivalent to this exponential equation. All right, moving along, number 3. Let's take a look at this example. 1 over 11 square is equal to 1 over 121. This is the example that was pictured in the opening of this presentation. So let's go ahead and attack it right now. So if you have 1 over 11 raised to the second power equals 1 over 121, how do you write this in its equivalent logarithmic form? What you do is you take a look at the base of the exponent. In this case, is a fractional base, 1 over 21, and that will be the base of our logarithm. Okay, so we have log base 1 over 11 of the fractional exponent right here, 1 over 11 square. So you take log base 1 over 11 of the left side of the equation, and you have to do exactly the same on the right side to preserve equality. Log base 1 over 11 of the right side of our equation, which is 1 over 121. On the left side, we see the cancellation action happening. The base of your log and the exponents are identical, so these cancel each other out. So you just left with the value of the exponent, which is 2. So 2 is equal to log base 1 over 11 of 1 over 121. So that right there is the answer to question number 3. Okay, let's take a look at number 4. So for question 4, let's say we have the exponential equation. Let's write that again. The exponential equation 49 raised to the 1/2 power is equal to 7. Alrighty, so how do we write this in its equivalent logarithmic form? So we just have to identify what the base of the exponent is. The base of the exponent is 49. So we're going to take log base 49 of both sides of the equation. So log base 49 of 49 raised to the 1/2 is equal to log base 49 of 7. So on the left side of the equation, we have the cancellation action happening. And then we just bring down the value of the exponent, which is 1/2. We have 1 over 2 is equal to log base 49 of 7. And that, ladies and gentlemen, is the answer to question number 4. Okay, let's take a look at number 5. So for question 5, let's say we have the exponential equation e to the x is equal to 7. Oh, there, this one looks a little bit different. We're looking at an exponent with a natural base here. So we have e to the x is equal to 7. All right, so how do we get rid of this exponent right here, e to the x? Remember, e is an irrational number, just like pi, right, and root 2. So how do we get rid of this exponent? Well, what we do is we take the log base e. So the base is e, the natural base. So we're going to take a special kind of log. Okay, it's not just any kind of log. Since the base is natural, we're going to use a natural log. Okay, so the natural log is ln. So you take the natural log of both sides of the equation, ln e to the x equals the natural log of the right side, 7. Okay, so the natural log and e cancel each other because there's an invisible e right here for the natural log. All right, so keep that in mind. So these two take each other out, and you're left with x is equal to the natural log of 7 as the equivalent logarithmic form of the original exponential equation e to the x equals 7. All right, let's take a look at number 6. Number 6, we have 10 raised to the 6th power equals 1,000,000,000, 1 million. So what's the equivalent logarithmic form for this exponential equation? So we have 10 to the 6 is equal to 1 million. All right, so what are we going to do here? Well, we have to find the base of the exponent and then take log base that base, all right? So the base of this exponent is 10. All right, so for number 5, the base was e, that is known, this is known as your natural base. This is a natural base situation for number 5, natural base. All right, so for a natural base, you use your common log. ln is known as your common log. I'm sorry. For a natural base, you use your natural log. Natural log. Okay. For number 6, guess what? 10, base 10 has a special name. This is your common base scenario. Common. Because we're working on base 10. Okay? So the two special logs to keep in mind is base e, the natural base, and base 10, the common base. All right. So what does that mean? Well, in order for us to get rid of this exponent right here with the common base of 10, we're going to take the common log, okay? So the common log is log base 10. So how do you write the common log? Well, this is how you write it. You take the log of 10 to the 6th power and the log of 1 million. So how do you know that this is a common log? Well, the way you write common log is you do not specify the base. Okay, if you do not specify the base of your log, it's automatically assumed that that is 10, your common log. Okay, so keep that in mind. log with no base is your common log, log base 10. ln is log base e. Alrighty, okay, so we're taking the common log of both sides. On the left side, since there's an invisible 10 right here, right? We don't normally write it, but I'm just going to write it there so you can see what's going on. So put a 10. So these two take each other out. And then we're left with 6 equals the common log. Keep mixing them up. The common log of 1 million. So remember, for common log, you don't put any number there. That automatically implies that the base is 10. Ladies and gentlemen, that's the answer to question number 6. All right, let's take a look at number 7. Let's throw in some more variables there. So let's say we have n raised to the m power is equal to 25. What's the equivalent logarithmic form? Let's do it. So if you have n raised to the m power equals 25, we just have to determine what the base is for this exponent on the left. The base is n, so we're just simply going to take log, wrong color, let me switch that. We're going to take log base n of both sides of the equation. So log base n of n raised to the m power is equal to log base n of the right side of the equation, which is 25, okay? So on the left side, you see a cancellation action happening. Log base n and this n are gone. So we have m is equal to log base n of 25. Alrighty, so that's the answer to question number 7. All right, let's take a look at one more example, then we'll give you some practice problems to try out to demonstrate mastery of this the information that we've been going over in the past few minutes. Okay, so x to the negative 11 equals 56. How can we write this exponent in its equivalent logarithmic form? So x to the negative 11 equals 56. All right, so we can clearly see here that the base is x. So what we're going to do is take log base x of both sides of the equation, x to the negative 11 on the left side, and log base x of 56 on the right. Okay, And then on the left side, we have the cancellation action happening. Log base x and x take each other out. And then you're left with negative 11 is equal to log base x of 56. That's the answer to question number 8. Okay, so now it's your turn to do some practice problems. All right, so we have 10 practice problems that we'll like you to try out. The instructions are the same as before. You have to write the exponential equations in logarithmic form. So go ahead and pause this video presentation at this time and try out these 10 practice problems. When you're done, click on the playback button, and then we're going to show you what the correct answers are. Welcome back. So hopefully you had a chance to try out the practice problems. Let's take a look at the solutions. The first one is let's write it this way. 3, actually negative 3 is equal to log base 3 of 1 over 27. Number 2 is equal to log base 20 of 400. Number 3, negative 1 over 4 is equal to log base 625 of 1 over 5. Number 4, 3 is equal to log base 1/2. Oh snap, I didn't write that properly. Let's write it again. 3 is equal to log base 1/2 of 1 over 8. For number 5, negative 2 is equal to log base 11 of 1 over 121. For number 6, 5 is equal to log base 2 of 32. For number 7, negative 5 is equal to the common log, log, of 1 over 100,000. For number 8, x is equal to the natural log of 3.2. For number 9, m is equal to log base 12 of n. For number 10, x is equal to log base y of 163. Alrighty, ladies and gentlemen, how well did you do in these 10 practice problems? Let's know in the comment section below how well you did. If you have any questions about any of these practice problems or what we covered in this presentation, just let us know in the comment section below, and we'll be more than glad to assist you. Thanks again for taking the time to watch this tutorial. If you found the contents helpful in your studies of logarithms and exponents, to give us a like or thumbs up. And don't forget to subscribe to our channel. Your positive feedback and subscription are extremely valuable to us. To gain access to tons of support resources, do visit our website at mathgotserved.com. Thanks again for watching, and have a wonderful day. Goodbye.